Let's discuss question number 46 from test 5. This is from strength of materials. Okay, so a solid shaft of 250 diameter has same. So you have a solid shaft and you have a hollow shaft. Okay, so solid shaft, the dia is 250. Let me write ds, which is 250 mm. The hollow one of the same material inside dia, that is d naught, is 200 mm. Okay, the outer is not known. Let's write outer, or let's write inner as di, outer as do. That is not known. Area of cross section is same. Okay, that is what one condition. Now we need to find the now angle of twist in equal lengths of the shaft. So if I take equal lengths of the shaft, how much is the angle of twist when stressed to the same intensity? So I am just applying the torsion on each of the shaft. Remember that one is clockwise and one is anti-clockwise. So I am just applying torque on the solid and on the hollow, and such that they are stressed to the same intensity. And I'm interested in the angle of twist. Angle of twist of the hollow, the angle of twist of the solid. Okay, so first is the area of cross section is same. So area of cross section, because it's circular, so pi by 4 ds whole square is the area of cross section of the solid shaft. For the hollow, it's just 2 cylinder minus, so pi by 4 d naught square is the area of the big cylinder minus di whole square. So this is ds square is d naught square minus di whole square. So this is 250 whole square is d naught square minus 200 whole square. So when I calculate this comes out to be, let me use a calculator for this. So when I calculate this value comes out closer to 320.156 mm. So this is the diameter of the hollow shaft, which we have just got from area of cross section balance, because that is what is given. Now they are stressed to the same intensity. So if I apply the torsion equation for both, that is for solid, let's apply for solid. T by J is tau by R is equal to your G theta by L. Okay, so now they are stressed to the same intensity, and we need to find out the area of, we need to find out the angle of twist. Okay, so what we will do is, we will just consider, because now if I consider the second and the third, because I don't know how much torque is applied, so I'll just consider the second and the third part, because they are stressed to the same intensity level. So if I go by this, the stress is same. The R is for the solid is ts by 2, the outer periphery. G is G, ts by length is same. Okay, so now if I apply for hollow, T by J tau by R is G theta by L. So if I apply second and third, because I don't know how much torque is applied, the stress is same. R is the outer periphery, which is d naught by 2, and G is same, theta hollow by length of, or lengths are same. So if I divide this 1 by 2, or basically 2 by 1, so TH by TS on the right side will be equal to d naught by ds. That's what I get. D naught by ds, which is 320.156 by ds is 250. So this is, it just turns out to be, oh god, let's first let's do it properly. I mean, I think we have messed up somewhere. So this is, let's divide 1 by both the numerator. So this is tau by ds by 2, this is tau by d naught by 2, and this is theta s on the right side, theta s by ds. So this is d naught by ds for theta s by theta h. Now d naught, So if I'm interested in theta h hollow by solid, so it will be ds by d naught. Ds is 250 mm and d naught is 320.156. so this ratio is basically 0.78 if you use a calculator, so 0.78, and therefore the answer for this is A. Option is A. These kind of problems where, I mean, this is quite simple, but sometimes your weight comparisons can be asked, how much material needed. All these problems, just understand what is given, and because of the torsion you need to always apply this equation, torsion equation, but then you have to be careful how you are applying. That's it. Thank you.